Hi, everybody. I'm Jasmine Dahilig. I'm a software engineer at HashiCorp on the Nomad team. I'll explain what that is in a second. And I'm here to talk to you today about package management for DevOps. Oh, click on the slides. Or how, in other words, how I learned to stop worrying and love package management. So I've been working on this project called Nomad for a couple of years. It is a distributed workload orchestrator, which effectively means if you have a cluster of machines and you deploy the Nomad binary to a number of them, you are able to automatically schedule all of your application deployments evenly across that cluster of machines using our distributed scheduling system, which uses Gossip and Raft protocol. So it's not a monolithic scheduler. It's not like you have one scheduler that is managing the entire cluster. For resiliency, we recommend actually a minimum of 3 servers. And then you could have three servers, which in Nomad terminology, the servers are the schedulers. And they're the ones that take evaluations of the state of the cluster, decide which worker nodes are sort of like filled up and which ones have space and where to deploy your applications. So you could have hundreds of clients, which is the Nomad term for basically like a task executor. Or a node that can run many task executors specifically. And for that task execution for your application runtime, we have a task driver plugin system. And this is all built in Go, both the scheduling servers and the worker clients. So if you have special types of task executables, different types of binaries or applications to run, such as Docker containers, Podman containers, Java jars, QEMU, virtual machines. I'm trying to list all of them. And if you have a different type of executable that you could go ahead and write your own task driver for the Nomad system. So in DevOps, I would describe DevOps as sort of like the hybrid between, or sort of where your application development and your operation runtime meet. So in this, I would describe that as a deployment. It's when your application software that you've been working so hard to develop, you actually have to have it running out in the wild. It's either going to be on your own personal machines that you're running in your home lab. It's going to be on a cluster of machines that you're running at some co-location data center, maybe that you're managing yourself, or it'll be in one of the big clouds. And now I need to preface this talk with a little disclaimer here. I never set out to build a package manager. When I joined the Nomad team, I had basically been working on distributed systems for all 8 of my years in application development. So I had gotten my hands deep into a lot of distributed systems, specifically for the Hadoop ecosystem with MapReduce and Spark and such. And I really wanted to try my hands at building working on an interesting, lightweight scheduling system that does more than just jars. So containers, jars, all sorts of application executables. But I never meant to build a package manager. But we were faced with this problem. Nomad, as a distributed workload orchestrator, it's super easy to use. It's only one binary to deploy. You put it on your machines and you can get a pretty simple application running really quickly. We've had users get up and running within 2 minutes. And we've had other users completely migrate their production from whatever they were doing before to Nomad in under 2 weeks, which is a lot faster than maybe some other scheduling systems that maybe take 2 years to migrate to. But we're running up upon this problem where for expert Nomad users, it's super easy to use. They've figured out all the details, but new intro users, there's not enough examples to figure out how to use it. So when you're talking about DevOps at scale, I'll address the typo in a second. You're talking about many teams, many projects, and many, 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 many deployments. Your company or your organization may also additionally have some standards. And all of this, at the end of the day, it boils down to a runtime deployment that is most often saved in a configuration file. If you're lucky, more like if you're smart, it's saved in a configuration file. A lot of times, I mean, back in the Hadoop land, when we were doing stuff there, the configuration was a bunch of command line args that were maybe generated at runtime and then passed in to the Hadoop yarn scheduler. Well, that's taken me back a minute. It's been a minute since I've worked on that. So most importantly, though, in the modern world of DevOps, you want to save all of the factors of your application at runtime deployment in a configuration file so it can be version controlled, maintained, and repeatable. But this typo was organic. I did type DevOps. I meant to type DevOps, but I kept it because a lot of times it can be maybe a little bit of DevOps at scale, especially if you aren't version controlling your configuration files, or configuration files become so sprawling that you can't really manage them. So going back to the hybrid of development and operations, DevOps, you have a deployment is at the center of that, which is sort of like the instance of your application running in real time somewhere on some machine. And so this talk is very much about expanding your concept of package management to not just be the management of the application itself and the binaries itself and where you're storing and saving those binaries, but also the packaging of an entire runtime deployment, which I would term as sort of a configuration management. So when I started this project, I didn't want to build a package manager. I thought that it would be, there is no way we'd build anything as cool as Pacman or some of the other package management systems. But we had this need where we really needed to improve the usability for our users. And so I saw that as a hybrid of automation and configuration documentation. So it's all around configuration, but it was a hybrid of the documentation of all the different examples that you possibly could have and an automated way to deploy those to the Nomad cluster very effectively. So when it comes to configuration management, there's a few core parts of it. There's templating, dependencies, and version control. So templating very much is about context-aware deployments. You will have, your sort of skeleton of what kind of application you want, but you need to be able to template at runtime where exactly it's going, what certain configurations, what namespace, what team, and all these different factors that are going to be a part of it. And Nomad currently has a few, or previously had a few solutions for that, one of which is the Nomad Project, which is sort of a predecessor to Nomad Pack, which is what I'll be demoing today. Then dependencies. We have some users that have job specifications. So a job specification is very much like the configuration of the entire deployment, which could include multiple applications running all over your cluster. So one job could mean many tasks, many executables running all over your cluster in some sort of limited ordering, whether they're co-located on the machine itself or spread out across the cluster. This could all comprise of one app job, which is basically like a set of applications. And so we've had some users where their jobs are so big that they are over 100, maybe 200 lines of configuration. And that in software engineering is super hard to manage. It can be really confusing. Additionally, if you have those organizational standards, that means that perhaps a lot of that configuration file is duplicated all over the company. And when you have duplication, there is room for error. Additionally, and finally, we have version control, which is basically like taking a snapshot of your deployment, like understanding and having that deployment be completely reproducible, completely repeatable, at any time. Now, I'm sort of leading into the Nomad Pack project, which was the solution to our usability problem. Nomad Pack is a pretty simple, lightweight command line tool. It's a community project that we built here at HashiCorp to aid our users to build our community in making Nomad much more usable. It's just a simple command line tool that hooks up to a Git repository where we have stored all of our community examples of different packs. And these packs are basically configuration sets. They're little configuration bundles. They can depend on each other, and they can be version controlled either in your own GitHub repository, which you can hook up to Nomad Pack, or in sort of the main community repository, which is downloaded by default at runtime. So I meant to have this slide at the beginning, so you didn't have to listen to me ramble on about all this. But if you're interested, you can go to Nomad Project.io and learn more about the Nomad cluster and sort of how just the inner workings of cluster deployment and distributed workload orchestration go. You could look at the HashiCorp Nomad Pack project, which we just built over the last couple months really quickly. And if you want to use or see examples of Nomad Packs, you can go to our Nomad Pack community registry. And this is where we would really like you all to join us in this effort of translating application deployments into Nomad Packs, Nomad job specs, so you could quickly and effectively run your applications with no problem. Currently, you could build the project yourself at the Nomad Pack GitHub project, clone it, build it, make dev, or you could download it from our releases site at releases.hashicorp.com. There were a bunch of boat metaphors that I had before, and I forgot to remove this one. But essentially, when you're when you're on a journey sailing into the cloud, you want to rest easy and sail into the sunset, which is what we were hoping to do with Nomad Pack. So now I will do a little demo. So the first thing I'll be doing is running my Nomad agent in dev mode. So as I said before, it's a single binary, but with a single binary, you could run two different types of nodes. There's the server node, which is the scheduler node, and that one it talks to all of the other nodes and understands sort of the state of the cluster and evaluates where application deployments should be placed when they're scheduled. So the server scheduler node, you want to keep that on separate machines from the worker client nodes, which is the other type of node you can run with the Nomad agent binary. The worker nodes, or the client nodes, are where your applications will actually be running. And because that could take up a lot of space, you want to keep those two separate. You want to keep your schedulers on different nodes from your workers, so that way they don't interfere with each other. But for the sake of development and this very quick demo, you could run it in -dev mode. This is also a really easy way to get started with developing Nomad. You could run it in -dev mode, and it just runs the server scheduler and the worker client all in the same process. So it's going to start up, take a second. So the Nomad binary is very lightweight. It's like 80 megs or something. Was it 25 megs? I should know this. But it's pretty lightweight. You only have to deploy the one binary and not a whole bunch of different things just to get your cluster to work. So that's running. You can do Nomad job status and interact with it there. And just see that there's no running jobs. So what we're going to do is Nomad Pack run, and we're going to run a Fabio load balancer, just a pretty standard proxy. And then that's it. So what Nomad Pack is doing is it checks the local cache on your computer for if you have the configurations the pack configurations downloaded already. If not, it fetches them from GitHub. Then it checks the Nomad cluster for status, and it talks to it and sends the job spec, which is defined in a pack, which defines your application deployment and then sends it to Nomad. So you could do Nomad, you could do job status now and see that it's running. So Nomad Pack also has a few other different commands which allow you to interact with the Nomad cluster for the packs you've deployed, like stop, destroy, status, etc. And the way that it's able to do this is through a super awesome project that was built recently by one of our engineers, Derek Strickland. It's the Nomad API project, and it's really cool. Or sorry, the Nomad Open API project, and it's really cool. It's conforming the Nomad API to the Open API standard, which makes it a lot easier for us to create SDKs to enable users to create more community tooling to interact with the Nomad cluster. So if you're curious about Open API and the Nomad Open API project, please go and check that out on GitHub. Also, a shout out to James Russell, who built the Levant project, which was a predecessor to Nomad Pack, because it was one of the first community projects to interact with Nomad separately from the Nomad CLI, and enabled our users to do a lot of templating, which is really helpful because the HashiCorp configuration language has a very, very limited amount of templating, not enough to enable our users to do what they fully wanted. So that's why we built Levant, and we moved forward into Nomad Pack. So that's basically it. If I have like 3 minutes left, I could go over the internal structure of it, but I won't burden you with that. Mostly I want y'all to check out the Nomad Pack project on GitHub, clone it, fork it, help us out. We have a lot going on the Nomad team, and we only have a handful of engineers working on all these different projects and features. So we're really hoping to build up our community developer experience. So what's next? We want to improve usability. We want to have much more tight integration with Nomad by improving the Open API project. And eventually, once Nomad Pack has reached a usability stability kind of benchmark, then we want to reintegrate Nomad Pack with the Nomad Core CLI so it can go back to being just one binary. Thank you.
Thank you, Jasmine. We appreciate your time doing this. This is super interesting. So I think we have a couple of minutes for Q&A. In case anyone has questions, I'm watching the Element room and the YouTube comments. So far, none.
Well, if you have any further questions, please feel free to reach out to me. I'm Jazzy Fresh on GitHub. And thanks, everyone. Join us on GitHub.